Alright, so I was having some issues before. I've started a new video now. What we're going to do though is the answer was C. And you can do it one of two ways. You could do solve system of linear equations. Or you could actually do the solve function and then have a space between the two functions and you can write and. I'll write it. You can write this in your calculator. You can write solve 2x plus y, oh my god, is, now it's doing this thing again, equals 150, space, and then type in and. Space, 3x is equal to y. What are we solving for? Comma. Let's just do comma x, comma y. Or we could just do comma y, and it'll actually find that out for us. Alright. I'm having some technical issues. I think it's due to the RAM on this computer, but I'm going to push on. The graph opposite shows which one of the following is true depreciation of the two cars. At the start, both cars have the same value. Is that true? No. Both cars were equal in value at 7 years. Yes. That's the intersection. Beautiful. Okay, if Cheryl buys 5 Turkish Delights and 4 packets of almonds, it will cost her $12.70. So, let's call Turkish Delights T. So what we're going to say is 5T plus 4A is equal to $12.70. However, if she buys 4 Turkish Delights and 3 packets of almonds, that is equal to $9.65. Once again, you've got 2 sets of equations. Let's see if I can do this again. 5t plus 4a. So let's try it again. Yeah, this is so slow. I don't know what's going on with my computer. All right. So we're going to go to menu, we're going to go to algebra, we're going to go to solve system of equations and menu, algebra, solve system of equations, solve system of linear equations. And what were our 2 variables? What did I call them one? Didn't we call the one t? Let's call one a and let's call the other one t, just like we have in the question. Okay, so what was the first equation, Andrew? 5t plus 4a equals 1270. 5t plus 4a this is ridiculous. I need to get more RAM on this computer. Memory plus 4a is equal to $12.70. And the last one wasn't it 4t plus what? Is equal to $9 is equal to 9.6. Gee, this is slow. Comma A, comma T. Now, how much is the cost of a Turkish Delight? 50 cents. How much is the cost of an almond? What is that? Okay, which is that in decimal. So, if I have a look over here, it's saying, so what's the answer? The answer is A, thank you. Solving sets of linear equations and solving them, that's all that is. Okay, extended response question. Karen wishes to rent a car for a long weekend. The cost of renting a Holden from company A is this. Now, which one is it? Look, which one has the higher gradient? This one or this one? B has a higher gradient, so we know that this is going to be B. This is going to be company B because it has a higher gradient, it has a higher slope. This is company A. Which company, A or B, does line 1 represent? So line 1 represents A. Pretty straightforward, yeah? What does the y-intercept for company A represent? The initial cost, thank you. Excellent. And the initial cost in dollars. Okay. State the point of intersection and therefore find the number of kilometres Karen would need to travel so that the car hires are equal. Now what we're going to do is state the point of intersection. It means that what can you tell me about the coordinate, the C coordinate there? The cost is the same. And we have two costs in terms of n kilometres, or n, what's n in? N is the number of kilometres travelled. So what we've got is we've got 25 plus 0. What we've got to solve is we've got 25 plus 0.15 n is equal to 40 plus 0.09 n. Now, we could do it in a calculator and you can do solve. That's what I want you to do. We've done it to death. But what I'm going to do is I'm going to use a little bit of algebra. I'm going to subtract 0.09n from both sides, which means I'm going to do this in my head. 0.06n would be equal to, and I'm going to subtract 25 from both sides, which is going to be 15. Now, if I therefore say that n is equal to 15 divided by 0.06, how many times does that go into 15? Well, it's going to go in, 250 times, is that right? Yeah. There you go. You don't need to use your calculator all the time, do you? You use it though, but you use the solve function. So how would we do it? We'd just solve 25 plus 0.15n is equal to 40 plus 0.09n, and then we'll do comma n, and you'd find that. Now, have we answered the question though? No. What does it say? State the point of intersection and therefore find the number of kilometres. So state the point of intersection. So where does it intersect though? When n equals 250, so we've got to therefore say when n equals 250, C is equal to, is this up here? 62.5. You need to sub it into one of these equations. If you sub that in this equation, you'll get that. If you sub it into the other equation, you're also going to get the same thing. So let's keep them to the end. What we're doing is we've found the n coordinate. We've found the n coordinate here. Now, in order to find n, we still don't know what that cost is. So we need to then sub n into our equation. And our equation is, we've got 2. And the thing is, the y-coordinates or the c-coordinates are the same. So when you sub in 250 into this, you're going to get 250 times 0.15 plus 25 is equal to 62.5. Okay? Now, so therefore we can say that the point of intersection is 250, 62.5. Okay? Now, if Karen travels to Portsea 130 kilometres away, which company should she use? Well, which company do you think she should use? Company A or B? A. Okay, so, first of all, Company A. Now, that's the correct answer. So that might give you 1 mark. But it says explain your answer. So explaining, so since they intersect at, it says 130 kilometres each way. What about if it was 120 kilometres each way? Which would be cheaper? B would be cheaper because 240 kilometres is less than 250. Can you see that? So this intersection here, this point is, what's that? 250 kilometres. So once after they've driven 250 kilometres, then suddenly the other one becomes cheaper. This one becomes cheaper. All right. So because this is 260 kilometres, since they intersect at 250 kilometres, and Company A has a smaller gradient. So after the point they intersect, that company is going to be cheaper for every kilometre after 250. Make sense? And they're going to be exactly the same cost at 250, at this very point of intersection here. Okay, this point here, that point there. Okay, a group of school-age tourists wish to go to the amusement park and need to decide which payment option is best. Now it says Compston's charges $14 per entry and $1 per ride. So no one rides, still cost you $14. But if for every person that rides, or every ride, it's increasing by $1. So therefore, if it's increasing by every one, it's going up one. Then this is what? It's starting with N. Linear. $4 entry for plus $2 a ride. So therefore, it only costs, if you didn't go on any rides, then you're best off going to Lakes Lunatic Launches. Okay, if you're going to just sit there and eat fairy floss, okay, then don't go to Compston's. But if you're going to do heaps of rides, you're probably best off going to Compston, because each ride is going up by $2. 6, 8, 10, 12, 14, 16, 18. Now at the moment, if you went on 7 rides, which one would you choose? You'd go to the old Lunatic Launches. But what about if you went on 20 rides? You'd be going on good old Compston's, wouldn't you? Okay, good. So it says complete the table below. That's an easy 2 marks, isn't it? State an equation for each option giving the total cost for rides. Option 1 equation. Well, that is equal to, Compston's was equal to $14, which we're going to say that the cost, total cost T, which is in dollars, is equal to 14 plus, what are we going to use for R? Right, okay, so plus 1R if you like.
Does it matter if you do R plus 14?
That's fine. R plus 14 is the same thing. Option 2 is it's cost you $4, but it's plus $2 a ride. So therefore plus 2R. So there you go. There's option 1 and option 2 equations. Once again, each worth a mark. Okay so far? Now it says here, so we've got 14 plus R and 14 plus R and 4 plus 2R. Now you can do this on your calculator. Now how do we do this? First of all, in your calculator though, your calculator won't recognise R. It recognises Y in terms of X. You could do it by hand, but I'm just going to show you that if you do it in your CAS calculator, we can go to menu and we can go to graph. And we've got to say though that Y, or the cost, which they both have, is 14 plus X. Enter. And we can even go menu, Windows zoom, and we can zoom out a bit. And go enter, enter. Alright. And then we can press Control G. And that adds another graph. And the other graph is what? 4 plus... Wow, I'm speaking to a bunch of mutes. Okay, 4 plus 2. If I write R in there, is my calculator going to recognise it? That's the problem. Don't go writing R in. Remember that you can just put it in X in terms of your CAS calculator. There you go. All right. Now, there's our 2 equations. Now, you can then use the things and you can say, all right, I want a menu and I want a Windows zoom. Oh, maybe I can analyse the graph and I can find the intersection. Everyone should be watching this. Okay, because the intersection, you can, from the graph, I can go from here and across there. Look at that. Can someone tell me when it becomes cheaper for good old 10 rides, okay? So, it's not cheaper, that's the point where they intersect. So this is how you can use graphs, and you don't have to use the solve function for that. You could though. How would we do it in the solve function in our calculator? Well, what we could do is we can go menu 3, 1, and what we can say is but the problem is we have to then find what the total cost is. We can say that 14, it's cracking it.
Isn't this just wasting time, though, sir? Because you're making a graph anyway.
Yeah, I know, I'm just showing you two methods. Yeah. I'm going to, this is really, okay, so I've just shown you how to do it in the calculator, but as you can say that we've got to mark this graph. Now, first of all, we've got to label it. What is this in? This x-axis is what? It's R, which is the number of rides, isn't it?
Yep.
And what goes up here, we've got, isn't this T, which is in dollars. Okay, so we've got two graphs. We've got 14 plus R. 14 plus R is equal to, so that's going to be an intercept of 14 because y equals mx plus c that is the y-intercept, isn't it? And you've got 4 plus 2R. Now, which of these has a greater slope? We certainly know that this one has a greater slope. So this one is going to go up, sort of like up here, where this one's sort of going to go across here or something like that. Now, if I rub that out, I just want to get you an idea of what it looks like. Now, the thing is, it says graph each option on the set of axes below. All we've got is the intercepts, but what does the gradient tell us? 14 plus R, for every time it goes across one, it goes up 1. So if we're going across 20, how far is it going up?
20.
It's going up 20. So what we need to do then is, if this is going across 20, we need to go over to here. We need to go over to here, and that point there is then going to go up 20 in terms of the y. So there you go. That's going to be our line, and we sketch just a line between there and there. Okay? So this is, was this Compton's? That was Compton's. That's the line Compton's. Now, the other one is 4 plus R. 4 plus 2R. If it goes across 20, how far does it go up? 40. Do we even have 40 here?
No.
So let's just sort of say that we're going to go across 20, we're going to go up 40, so it's going to go up to 44. So let's just sort of say that this is this point here. And therefore, and where did we say they meet?
24.
Didn't we say when 10 rides?
Oh, yeah, but then actually...
So let's just sort of like get an idea. Oh yeah, that's going to be pretty good. Okay, so let's, at 10 rides, they cross, and then we're going to work out how much it cost. So therefore we can say, make sure you label each graph with its equation, label your axis, and at least 2 points on each graph. All right, so here's 1 point. What's this point? This has the coordinates 0, 4. What about over here? This is 20. It's got to go, wasn't it 44? You don't have to pick these points. You can pick any points. This is 0, 14. And what was this one over here? 20, 34, yeah?
So for you and yours, intercepts at 10 lines, at 24 lines, at 24, yours is at 22. And on the calculator it says that 24 as well. Does that matter?
Where are you talking about?
So like, you know how where that intercepts right at 21 there? So it's
Yeah.
10, that's the line, that's where it intercepts, like that's the coordinates.
Yeah,
The
yeah.
calculator says 24, 10.
No, 1024 you mean.
24.
Yeah, that's right. So that's the thing. In the CAS calculator, yeah, you're right. It's the coordinates of 1024, which means this line isn't to scale, is it?
No.
So I've clearly made a bit of an error there. And that's the last thing you want to do. So I've drawn this very roughly, but yeah, you're right, Deej. This point here, where they intersect, and we showed that on the calculator, was at 10.24, which means that this line really has to be up here somewhere. And this isn't a poorly designed question, because I guess the whole 2044, you'd expect that maybe this graph would go up a little bit more. Okay? What? Now, it says here, if you had $22 to spend, which option would you go on? Which option would you go on? Given that they intersect at $10 and $24, which one's cheaper, this one or this one? So, yeah, that's right. It's the lunar launches or whatever it is. And you know why, because you would then sub in that point. Oh my God, this is doing it again. Not good, not good. Hello, all right, we're back in the room. All right, so launches, and you know why, because but you need to explain, you need to sub in the point or the cost T equal to 22 into both. And Compston's will be more expensive, so therefore you've proved it. How many rides would you need to purchase so that the cost is the same? Didn't we just go through that? 10. Thank you. Awesome. Okay. Now, we've now got this last question, which is involving revenue. Okay, I'm going to do this as quickly as I can. But the one concept we really haven't covered is the concept of business, which is that money in minus money out is how much money you make. In other words, profit is equal to your revenue, how much money you're getting in, minus your cost. Now, the rock climbing activity is run at a cost of $220 per day to pay the instructor, plus an additional $8 to cover equipment. So, what we need is write an expression for the total cost. The cost is equal to $220, which is set. Oh my God, it's stalling again. My computer's spitting it. Sorry. 220 plus 8. 8 what? N for Nelly, is it? Good. That's it. No, because charges school kids. Is that part of their cost? That's their revenue, isn't it? Think about it. We'll write an expression for the total cost. No. Write an expression for the total revenue. Money they're getting in is revenue. Okay, this is money that they have to spend, like they have to pay their employee $220 and they have to buy equipment and stuff, and it's on average $8. So when it comes to revenue then, the revenue is equal to, well, how much money are they getting in? Harris, Geddick. How much money are they getting in? What's the revenue equation? No, Harris. I want you to think about it. I'm gonna wait for you. $26 per student. And students are N. So how would I write that as an equation? 26 26N. Think about 20 students. 20 students times... Okay. Then please continue to follow. If profit equals revenue minus cost, write an expression for the profit. Profit is equal to revenue, which is 26N, minus the cost, which is 220, plus 8N. Now I'm going to do some simple algebra. 26N subtract 8N is 18N, minus 220. And that's it. Now, the company then also runs kayaking groups. The amount of profit made for N students in the kayaking group is given by this equation. He decides to take 30 students. What is the profit? Well, just subbing in. N is equal to 30 then the profit is equal to 30 times 17, which is 510. Take away 310 is equal to $200. Simple substitution. And finally, the accidental decides that the kayaking activity would only be worth the effort to run if they made a profit of at least $460. How many do they need to sell? Well, if this is $460, you can solve it. And you know what? We're going to do it by hand. 17 times n minus 310. What am I going to do to both sides? I'm going to subtract or add 310. I'm going to add 310. What's that going to give me? 770 is equal to 17n. Now what? If I divide 770 by 17, what do I get? What is it? 45.3. Now, given that they need 45.3, and we're talking about how many students do they need, would we round up or down? Up. So the answer, and only accepted answer, is 46 students. All right, can you please give yourself a mark out of, what was the test out of, 32? And I'd like you each to share with me what your mark was.
Well, I've been changing my work